Alrighty, second half of 4.1, 4.1b. So recall that we were just talking about, last time we were talking about solving systems. So a system is two or more equations, right, where the x and the y mean the same thing, or they're solved. And they have solutions, right? A solution, a common intersection point. So solution is common intersection point. You can find that either via graphing, right, which isn't the most accurate method, but you can do it. But it's much preferred to use substitution or elimination, right? Now, on your last homework, I did ask you to solve via each one, right, either through substitution or elimination, but it's really up to you now which one you would like to choose. There's certain systems will work better with substitution, as we saw. Certain systems will work better with elimination. So it's really up to you which one you would like to work with. So let's go ahead and try one now. We have two systems here, and I'm going to do one by substitution, one by elimination, just so that we remember how both of them work. Alright, so we have this system here. 2x minus y equals 3, and 6x minus 3y equals 9. Now actually this system is an example of one that will not work, right? So if you're having trouble with substitution or elimination, this may not be the best example for you to work with, but please make sure you come get help with those. So if you remember from our last example, we did elimination. Elimination's where you take out, you add them together, and then you can eliminate a variable that way. Substitution is where you sub one in and find it. But I'm going to do this with elimination, actually. I take back what I said. I'm going to solve this with elimination, and you're going to see why this one actually doesn't have a solution. Well, it has infinite solutions, but we'll talk about that in a sec. So let's pretend I don't know that. Let's pretend that we're just working along. It's any other day. It's a systems problem. I say, okay, I've got these two equations in my system. I'm going to multiply this first one by -3 in order to eliminate those y's, right? So I want to make that second one +3 so that it'll eliminate with the -3, right? So let's go ahead and do that. We'll rewrite it over here. I get -6x plus 3y equals -9. Sweet. My second equation is 6x minus 3y equals 9. Right? Just like that. And now we see the problem. What's going to happen when I add these two together? Well, it's definitely going to happen what I want to happen. Those y's are going to eliminate. But what else? If I add these two together, -6x plus 6, 0. Then 3x plus -3y, or sorry, 3y plus -3y plus 0. And -9 plus 9 is equal to 0. I get a whole mess of zeros. Which means what? Well, it means first off, it definitely doesn't have one solution, and definitely not going to find an ordered pair where they work. But it means that actually these are the same equation. They're the same thing. They're just rewritten. Well, one has a factor of 3 in it. It's just the second one is being multiplied by -3, as we just saw. So this is actually the same line. And remember, when we were talking last time, this is that 1 out of 10 equation where they are the same line, right? And so what do they have? They have an infinite number of points in common. If you get a row of all zeros, or something that makes sense, like 6 equals 6 or 0 equals 0, right? If it makes sense, then what you have is infinite solutions. So this is the same line, the same equation, and so it has infinite solutions. So that's the first thing that could happen, right? That's the first thing that you can see, that 1 out of 10 case. We also talked about another 1 out of 10 case. Let's see if it happens in this next one. So again, we're going to pretend that we don't know anything's wrong, where we're going to go along and we're going to solve this just like any other equation, and we're going to say, okay, and first off, there's a typo. I do apologize. This first one should be 2x. That's already how we know it's not going to work, right? But that's not the reason. So assuming that this one didn't have a typo in it, it's going to be -2x. It's going to be x plus 3y equals 4, and -2x minus 6y equals 3. So let's go ahead and solve this. I'm going to do it by substitution. Let's solve this by substitution. So let's say I'm going to take this first guy, because this x is all by itself, right? And I'm going to substitute this into the other one, but I want to get x all by itself first. So I'm going to move that 3y over. I get x is equal to -3y plus 4, right? Because that's how I start substitution. I want one variable by itself on either the left-hand side or the right-hand side. And now I'm going to take that that thing I know x is equal to this expression. I'm going to put that expression in here for x. I'm going to substitute that in. So instead of x, I'm going to write what I know about x. I know it's equal to negative 3y plus 4. And that would be minus 6y is equal to 3, right? So I've substituted that in, and I can now solve because I only have y's left. Now I only have y's. So let's go ahead and distribute that. I get 6y minus 8 minus 6y is equal to 3. And I've got some like terms to combine. 6y minus 6y, those go away. I'm left with negative 8 is equal to 3. Wait, what? Negative 8's not equal to 3. What are you talking about? So it looks like, in this case, with all the algebra correct, the y's went away. Not only did the x's go away, but the y's went away. And what I was left with was absolute garbage. This is not true. Negative 8 does not equal 3. Only 3 equals 3. And negative 8 equals negative 8, right? It's the kind of backwards world are you living in. So this is one of those cases where we actually have parallel lines. We have the same slope, but 2 different y-intercepts. And so we have something that looks like this going on. And they say, okay, look, so where's your intersection point? There isn't one, there isn't a point, and you can tell that because negative 8 does not equal 3, right? So this would be no solution. Alright, and so up in the last one, we got something that did make sense, right? 0 equals 0, and that's a true statement. 0 equals 0, so therefore they are the same line. They're exactly the same. In this one, they were parallel lines. They had different y-intercepts, and so they never cross. This is no solution. It's not that they're crossing everywhere, it's that they don't cross, so it's no solution. So watch out for that. There are two different cases you can see where it ends up being different, right? But that's just a little reminder on how each one of those works, the elimination method and the substitution method. Even if I had switched those, even if I had done substitution this way or elimination that way, we would have yielded the exact same results. We would have gotten that this is the same line, and we would have gotten that this is these are parallel lines. Alrighty. Let's talk about applications of these now. So we've kind of talked about this to death. We've talked about how to eliminate and substitute. You've done homework on it. But you're probably wondering, because I said before that this is so applicable, right? This is so applicable to real life. And you might be thinking, yeah, okay, sure, she says that all the time. But this is actually true. And this section is not covered in your textbook, so watch out. But we're going to talk about it because it's so important about where you would find these things in real life. Linear applications, or linear equations in general, are used to model real life. We saw that in the last chapter, right? We saw that where you're getting gas at a gas station, or you're, trying to figure out your paycheck. It happens a lot where you think about these things. You may not use actual x equals how much gas I put in the car, but you think about this linearly, and you think about how you basically solve these equations in your head as you're going along. So systems are used a lot the same way. They're used a lot to model a lot of business. Like, where would you find, so I need this much product and that much product, and I need these things to happen. Go ahead and solve this for me. So it's a lot of building it the same way we built the last time. So let's jump down. Again, you've got, when creating these, there is no set defined way to actually do this. So instead of your steps here, start with this step, and this step, I gave you more guidelines for this one because unfortunately with real life, it doesn't like to follow steps. It just really doesn't. So here are some things you should consider as you go, and this is probably the order you should consider them. You may not use all the steps. You may not use any of them. You may end up doing something entirely different. But these are sort of guidelines, probably in my opinion, the easiest way to tackle these kind of problems. So let's look at these guidelines. Let's look at these a little bit. It says read the problem and identify the 2 variables in the question. In our last sections, there was only one variable. It was x, right? And then you would solve x and you would end up getting y. Now I know that sounds a little weird because we only defined one variable, I should say. We just still had 2 variables, but here we're actually going to define the 2 variables. They mean 2 different things. Then we're going to create 2 equations from context, 2 of them. We're going to need 2 equations. So we're not just going to create one like last time and solve it for whatever variable they tell us to solve it for. We're going to create 2, and then we're going to solve the system using whatever method we prefer. And then we'll check that they actually work, because sometimes in context, it doesn't make sense. Sometimes you get things like you are pumping gas and you need to put gas into the tank and you put in -5 gallons of gas and you're like, what do you mean x is equal to -5? That can't be possible. So we're going to see stuff like that as well, stuff that doesn't make sense. Let's take a look at this first problem. All right. Ticket sales to a local gaming convention, PlayerCon, are on the rise. Sales of 2-day tickets brought in $188,100. A total of 6,600 tickets were sold. Adult 2-day tickets cost $36, and children's 2-day tickets cost $26. How many of each kind of ticket were sold? If you're like me, you know that things like PlayerCon are probably a little more expensive than $36. I know I just bought my tickets for Comic-Con, and holy crap. So, never mind. Definitely a little more expensive, but we'll work with these ones since they're pretty simple. So, let's start with defining those two variables, identifying the two variables from the question. From the question, how many of each kind of ticket were sold? That's the important part, right? Each kind of ticket. When it says stuff like each, you know there's more than one of them. So what I'm going to do is I'm going to call X my adult tickets, and I'm going to call Y my child ticket, my children's tickets. I don't know either one, right? I don't know how many of each were sold. That's kind of the question. So when I get an actual coordinate pair as an answer, I can answer that question. I have 4 adult tickets and 5 children's tickets. 4,5 is my answer, right? So that's the point. You want to set it up so that your variable answers your question. That's why you pull it out of your question. Now from there, I need to come up with 2 equations about these tickets, right? And they may not look like it, but they've given me enough information to say 2 things about these equations. The first thing I can talk about is the total price. I can talk about the price of the tickets. So let's talk about that. The adult tickets cost $36, right? And the children's tickets cost $26. And there was a total of $188,100. So if I look at this carefully, and I wanted to think about the total price, well, I know eventually it ends up equaling $188,100, right? $188,100. And then another way I can write the total is $36 per adult ticket plus the $26 per the child ticket. So now I've come up with my first equation. This is talking about the price. $36 times the number of adult tickets I have plus the $26 times the number of children's ticket I have gives me a total of how much money was spent on, or how much money was gained from the tickets, right? Let's do the same thing with the actual physical number of tickets. So this will be the number of tickets. So now we're no longer talking about money. We're talking about physical little cards that have tickets on, that are, qualifier tickets, maybe badges or whatever. I know that there were a total of 6,600 tickets, right? So again, I know that it's supposed to equal 6,600. 6,600. But how can I represent a total with on the other side? I've kind of run out of coefficients here. I've run out of numbers. So what would I look like on the other side, the total number of physical tickets? Well, let's think about it. X is the number of adult tickets, and Y is the number of children's tickets. How would I write a total of adult and children's tickets? That would be an X plus a Y. All right, so think about that those translating skills. X plus Y would equal 6,600, means all the adult tickets plus all of the children's tickets is all of the tickets, right? The 6,600. And now we have our system. All right, sounds good. I'm going to solve this real fast over here. I'm going to use substitution. So I'm going to take this second equation, I'm going to solve it for Y. This would be equal to Y is 6,600 minus X, right? So I just move the X over. Now I'm going to take that and I'm going to plug it into the first equation. So this is just substitution from last time. I take this pink equation, it's rewritten, I'm going to plug it back into here, and I'm going to do that. I'm so running out of room, sorry about that. But I'm going to plug it back in. So I have 36X plus 26. Now instead of Y, I'm going to write what Y equals. 6,600 minus X. And that's still going to be equal to 188,100. Yikes, that is a horribly written equation. I do apologize. Solve this out, we end up getting with, okay, so we have 36x, 36x minus 26x. Nope, plus, yep, minus 26x plus 6,600 is equal to 171600. And that is still equal to 188100. That's 10x is equal to, sorry, I'm doing this as I go. So 10x, whoops, is equal to 16500, or x is equal to 1650. Great, what question did I just answer? When I solved that x was equal to 1650, what did I actually answer? I answered that that is the number of adult tickets, right? That's why it's important to kind of define your variables up here. So there are 1650 adult tickets. How am I going to answer the other part of my question? How am I going to answer how many children's tickets there were? Well, I can take it, and substitution is so nice to us because they give us such easy equations to go back and plug into. But again, elimination is just as fine. But with substitution, I now can just take that 6,600, subtract out the number of adult tickets. In other words, y is equal to 6,600 minus the 1,650 that are adults, or 4950. So it looks like this must be a Nintendo convention. I'm sorry if I've offended anyone, but those tend to be more the children's games. So it looks like there's a lot more kids going to this ClairCon than adults. Maybe they're considering over 21 as adults, because I don't know. I would go to a ClairCon, but all right, whatever. Whatever you're saying. I'm one of those 1650. So it looks like we've answered both questions. There were 1650 adult tickets and 4950 children's tickets. All right. Let's do the second problem together as well, because it's very, very similar. But let's, before we even try to tackle that, go ahead and pause the video now if you have any questions about how we define the variables, set up the system, and then solved it using substitution. Alrighty, let's take a look at that second one now. Sales of 3-day tickets at PlayerCon brought in $37,600. The combined cost of one 3-day ticket and a 3-day adult ticket and one 3-day children ticket is $90. 1/3 more adult 3-day tickets were sold than adult 2-day tickets. 1/5 more adult 3-day tickets or children's tickets were sold more than 2-day tickets. What was the cost of a 3-day adult ticket and a 3-day children's ticket? This is a little strange. So it builds off of last time, right? So 1/3 more than were sold than 2 days and last days. You know what? We're actually going to skip this problem because it involves a concept that I don't really like. So we're going to go ahead and skip B. I take that back. We're not going to do B. I don't do this often, but we're going to skip B because I don't like it. Instead, we're just going to move on to 5.2. Alrighty. Okay, 5.2. So we've got this system of equation problems, right? When you reverse the digits of a certain 2-digit number, you decrease its value by 54. Find the sum of find the number if the sum of the digits is 8. You may be thinking, holy heck, what are you talking about? There's such little information here. You're thinking, how can we possibly get a whole system like we did out of the last problem? The last problem had like 4 different sentences for us to pull information from. You're absolutely right. It seems like there is not a lot of information here, but there's actually quite a bit. Let's start with something. First off, let's start with what we should always start with, defining our variables. It's very important that we define our variables here because it seems like we're only talking about one answer, right? But there's actually 2. I'm going to define the x as this first digit, and I'm going to define the y as the second digit. Now, in order to do this, this will create my number, right? So at the end of the day, if I had x is equal to 5, y is equal to 4, I know my number is 54. Now, it's probably not going to be that. Or, if my number is 10, if x is 3 and y is 2, then I know my number was 32. That way I can kind of build that at the end. So I'm just using a little trick here. The way we set this up, though, is going to kind of give us Anyways, it's going to make us do a little trick, but it's definitely going to be the easiest way to solve this problem. Let's start with, let's build those equations, right? Let's build those equations that involve these two variables, just like in the last problem. These ones, though, might not be so similar. Let's start with that second part. Then find the number if the sum of the digits is equal to 8. Well, how would I represent the sum? That would be nice, easy. X plus y is equal to 8, right? X plus y is equal to 8. So there's our first equation. That one was pretty straightforward. The second one comes from that first sentence up there. When you reverse the digits in a certain two-digit number, you decrease its value by 54. We have to be very careful with this, especially the way we've defined our x and y. If I were just to write something like xy is my number, minus 54 is going to be the reverse of my digits, yx, right? If I could write something like that essentially, but that wouldn't be quite true, right? Because what I've written here is x times y. When I'm multiplying my digits, I haven't written that my digits are sitting next to each other, right? So this is not what we'd want to write. This would not be our second equation, because it doesn't match how we've defined our variables. Instead, what I want to do is be able to build our number with our variables. Now let's think very cautiously here. If I knew both of these numbers, I could just write next to each other, right? Like we're saying, if it's 2, 5, then the number is 25. But that doesn't really represent the whole number. Notice I said 25 instead of 25, right? We don't say numbers like two numbers in a row. We say them with their place values. So in order for me to write this number, technically, I'm going to have to multiply that x by 10. Think about that. Think about that for a sec. If I knew my number was 25, if I knew that that's what x, y was, right, that's what I knew it was, then what I'm really saying is not that 25 is x times y, right, because 2 times 5 is not 25, it's 10, right? But instead what I'm saying is 25 is 10 times my x value, right? If x is 2, then I have 20. I need to get to 20, so I times it by 10. And then add it to my y value, my 25. So this is sort of an equation we can come up with if we knew the number. And we're going to kind of build off of this with that information they gave us. But right now I'd like you to pause and go over this if that didn't make sense. One more time, 10 times x, if I knew it was 2, plus y, if I knew it was 5, give me 25. So this is sort of just like a concept we're using. Alright, pause here if you have any questions. Now what I'm going to do is I take this idea and I'm going to build something around that equation. So I know that my number, I can represent my number by 10x plus y. That's what my number equals, right? It doesn't really help me because pound sign I can't really solve for. So that's just an idea for now. I know that this number, 10x plus y, is going to be decreased by 54 when I switch it around, right? So if I were to talk about my switched number, well, what would that one look like? Oh, sorry, that doesn't even look like the word switched. My switched number, my reverse number, well, it's going to be flipped around. This time it's going to be the 10 times the y, right? In other words, if I knew it was 25 and I wanted to switch that to 52, I would multiply the 5 by 10 and add to the 2. So my switch number would be more of a 10y plus x kind of situation, right? And again, if that didn't make sense, make sure you pause the video and talk about it. So that would be my switch number situation. Now I know something about these two expressions. I know that the first one, if I reverse it, I've decreased its value by 10. So this first one, take away 54, would be the second one. So my second equation actually comes down to 10x plus y, my first number, minus 54, is equal to that switched version of my number. So notice, this is a lot of information given these two sentences, right? Just because, but now I successfully have two equations. We can simplify the second equation. We definitely should because it really doesn't look like something we're used to. Let's go ahead and simplify that just a little bit. So I've got 10x plus y minus 54 equals 10y plus x. Let's go ahead and switch this around so that the constant is on one side and the variables are on the other. So I'm going to move minus 10y plus 54 plus 54 and subtract x. I'm going to do that all at the same time. So I end up with my second equation being 9x minus 9y equals 54. And there is my system. And then my other equation was x plus y equals 8. Alrighty. So now we're going to go ahead and solve this using probably substitution again, since we have that nice little x plus y equals 8, right? So let's go ahead and solve that. I'm actually going to write this just a little bit smaller so we have room. So 9x minus 9y equals 54, and x plus y equals 8. Let's go ahead. This first one becomes 8. No, it doesn't. Becomes x equals 8 minus y, right? And that's totally fine. If you wanted to solve for y instead, you're more than welcome to. Just solve for one of them, and we'll plug it back into the other one. So now we've got 9 times 8 minus y plus y, nope, plus minus 9y, pardon me. Minus 9y is equal to 54. So I've substituted this part into the x value. Alrighty. Now I can distribute. 72 minus 9y is equal to 54. And that leaves me with 72 minus 18 is equal to 54. So I have negative 18y is equal to 54 minus 72 is definitely going to be a negative number. Negative 18. And then therefore y is equal to 1. So I know y is equal to 1. Now I can use any of these equations we had originally. I can use this one. I can use this to find my number. I can use this to find, sorry, that's just an expression. I can use this equation or I can use the top one or the bottom one, and I can find my x values. So x plus y equals 8. X plus, since I now know that y equals 1 equals 8, x must equal 7. And so it looks like my number is going to be 71. We can double check that. Sum of the digits, definitely 8, right? 71 take away 17 is 54. So when I reverse that, I get 17, right? And then if I take away 71 minus 17, I do get 54. So just to review this problem, I want to define it with digits, but because I've defined in this digit mode, I have to go through this little addition to what my number would be, right? And that's probably the hard part. After that, I created two equations, solved them by substitution, and found that my number is equal to 71. All right, let's try another one. Excuse me. Just going to rewrite that so it's not written over our words. Alrighty. Carlos and Kim are selling flower bulbs for a school fundraiser. Customers can buy a package of tulip bulbs and bags of daffodil bulbs. Can buy packages of tulip bulbs and bags of daffodil bulbs. Carlos sold 6 packages of tulip bulbs and 8 packages of daffodil bulbs for a total of $94. Kim sold 7 packages of tulip bulbs and 1 package of daffodil bulbs for a total of $43. Find the cost find the cost of 1 package of tulip bulbs and 1 package of daffodil bulbs. A lot more information here, right? So a lot less conceptual thinking for us based on the last problem. Very similar to that first problem, right? You hear these things over and over and over again. They talk about the tulip bulbs and the daffodil bulbs. Excuse me. Of course, I'm losing my voice right now as I'm making a video. My apologies. Okay. So they talk about, right in the question, find the cost of each one of the packages. So each one of the tulips and each one of the daffodils. And that tells us what to define our variables as, right? So x is equal to the tulips. Y is equal to the daffodils. You were not a fan of the last problem, you'll probably be more a fan of this problem, right? And I totally spelled daffodil wrong, but I just don't care. Alright, tulips and daffodils, right? And once we find a coordinate pair, we're able to answer our question. So let's go ahead and do that. Now we've defined our two variables. Next we need to come up with two equations. So let's talk about one dealing with Carlos. Carlos did what? Carlos sold 6 packages of tulip bulbs and 8 packages of daffodil bulbs for $94. So if I translate that, what's it gonna look like? Well, it's gonna look like 6 times the tulips plus 8 times the daffodils is $94 total, right? And that's comes straight out of that. I'd like you to pause the video now and see if you can come up with the same kind of equation for Kim and what Kim sold. She's gonna be our second equation. What did Kim sell? Let's go ahead and pause here and try and figure out an equation for Kim. Alrighty, hope you had a chance to try this out yourself. It says Kim sold 7 packages of tulips and 1 bag of daffodils for a total of 43. So we have 7 tulip plus 1 daffodil equals 43. And there are 2 equations, right? Very nice, easy equations to work with. This one, not so easy to work with substitution, right? I mean, there is a y there. We definitely could work with substitution. I wouldn't say it wouldn't be easy. I would just say maybe you might see that you'd want to use elimination. And since we haven't used it in a while, we're going to use elimination together. So let's go ahead and solve this using elimination. I think in order to get these 2 y's to cancel, I'm going to multiply that second one by 8. So my system right now, 6x, my goodness, I'm not going to use that color because it's hideous. 6x plus 8y equals 94. And then I'll multiply this second equation by a negative 8. So negative 8 times 7 would be a negative 56, minus 8y is equal to negative 344. And remember I told you sometimes these get pretty big. That's okay. It doesn't matter that this is going up into the negative 344, right? It doesn't matter that it's a big number or even a small number if you really think about it. But, because at the end of the day, big numbers are just big numbers. That's really all they are. They just do the same things that regular numbers do, small numbers do, just they're bigger. That's really the only thing to care about them. Alright, so let's add these bad boys. We end up with the y's canceling, and we get negative 50x equals, see, 94 plus a negative 344 would give us a negative 250, and therefore x is equal to 5. If we divide negative 50 on both sides, x is equal to 5. So even though we bounced all the way up to negative, or say all the way down to negative 344, x was still equal to 5. Good. What does that mean? X equals 5. What was the point of all that? Why does x equal 5? In other words, what did we just answer? That's right. If we look back at our definitions, that's the number of tulip bags. That's the cost of the tulip bags. So $5 per tulip bag. I'll write that over here. $5 for tulips. And how are we going to go find how many dollars for daffodils? Well, we can take it, we can plug it back in either one of these equations, or even that big one we just created. But why don't we go ahead and do the second one, just because it's got that 1 by. So 7 times 5, now we know x is equal to 5, plus y is equal to 43. And so 35 plus y is equal to 43, subtract y is equal to 8. Looks like $8 for daffodils. That makes sense because daffodils tend to last longer than tulips. Daffodils. Alright, whatever. So $8 and $5. That one was a much more straightforward problem, but we always have to make sure we answer the question in terms of the question, right? We don't want to just say 8 and 5, x equals 8, y equals 5, because they're like, okay, cool, I didn't ask you about 8 and 5, I asked you what the cost of the package was, you dummy. So if you told that to one of your customers, they'd be like, okay, I'm going to go next door buy, but instead if you told them $8 for daffodils and $5 tulips, then they might actually, think that's a good deal and buy it from you, right? So make sure you always report back in the context of the problem. Alrighty. We're going to do one more together, but I'm actually going to have you guys try it on your own first. So go ahead and try this, and then we'll reconvene after a couple minutes, and we'll do it together. Alright, so I hope you've had some time to try this on your own. We're going to do this together real fast. Sanji and Adam each improved their yards by planting daylilies and shrubs. They brought their supplies from the same store. Sanji spent $78 on 6 daylilies and 2 shrubs. Adam spent $113 on 7 daylilies and 6 shrubs. What is the cost of 1 daylily and 1 shrub? So again, I wanted to find my x and my y. It comes straight out of the question. 1 daylily and 1 shrub. So x will be daylily, and y will be a shrub. Alright. Oops, there's no c. Whatever. Shrub. Alright, now I'm going to come up with those 2 equations. One about Sanji, and one about Adam. Alrighty, it says Sanji spent $78 on 6 daylilies and 2 shrubs. So I hope you came up with 6 times the daylilies plus 2 times the shrubs equals 78, right? And then for Adam spent $113 on 7 daylilies and 6 shrubs. So 7 daylilies and 6 shrubs is $113. Okay, I'm going to go ahead and solve this by elimination. I'm going to times this first one by 6 and times the second one by -2, because remember, what I'm shooting for is for these y's to go away. I want these y's to eliminate, and they only eliminate when I add, right? That's why I need to multiply the second one by a negative. I don't want to subtract them away, so I want to multiply by 6 and then multiply by 2, because then I'll add together and get 24, and that wouldn't work. I want them to add together to get 0, so one of them had to be negative. Alright, let's try that over here. Or let's actually go ahead and compute out those multiplications. So I end up with 36x plus 12y equals 468. And then I'll times -2 to the second one. I get -14x minus 12y minus 226. And now I will add them together. I will not subtract, I will add them. I end up getting 22x. The y's cancel, just like I wanted. And 468 plus a -226 plus is 244. Sorry, 242. Alrighty, and just like I wanted my x or my y eliminated, I'm just left with this x equation that I can solve. Divide by 22, I get that x is equal to 11. So now I have answered the question that it is $11 for a daylily. However, I haven't answered the entire question yet, so I've answered daylily. I still need shrub. So let's take that 11 and let's go plug it back in. Plug it back into either one of these. I think I'm going to plug it back into the second. No, let's plug it back in the first one. 6, I don't know why I keep choosing the screen. 6 times 11 plus 2y equals 78. So notice now that instead of x, I've substituted in 11. So I'm substituting it in and solving for the y. So 66 plus 2y equals 78. 2y equals, so subtract 66 to both sides. That's 12. And y equals 6. And so it must be $6 for a shrub. And now I've answered the question. Notice I'm trying not to box my x and my y. I mean, for here, clarity's sake, I am. But really, the answer at the end of the day is this $11 for a daylily, $6 for a shrub. Okay. Alright, so the last thing I want to show you, you're not actually responsible for, but it can extend to 3 dimensions here. Everything we've been talking about with these systems and stuff can expand into the 3-dimensional world. Right now we've been talking about a graph, a 2D graph, where they intersect, right, and what solutions you can get out of that. But you can actually solve systems of 3 variable equations with 3 equations. You need the same number of variables and equations. Again, you're not going to be responsible for one of these, but I want to show you kind of what they look like. And if you're pressed for time in class, you can go ahead and just skip over this part. But I think it's super interesting, especially when it comes to what these guys look like. So I'm going to start with that. These guys look like this. So check those out. Isn't that really cool? These are three-dimensional equations. So this is what happens when you plug a three-dimensional equation into like a computer program, and they turn out looking pretty cool. Alright, cool. So let's see about this. We're going to solve it via elimination, and we're going to do it a couple times. So I'm going to start by picking any two that I like. I'm going to start with, let's see, I'm going to go with the second one and the third one, just because why not? And I'm going to eliminate one variable at a time. Do this process like 3 times. Eliminate a couple things over and over again. I'm going to eliminate z, I think. So I'm going to go over here. I'm going to call it 1. And I'm going to multiply 3x minus 5y plus 2z equal to negative 8. I'm going to multiply that by 7. Oops. And then I'm also going to take that third equation, 5x plus 3y minus 7z equals 0, and I'm going to multiply that by 2. So it's nothing new, right? I'm going to multiply so that the z's cancel. That's all I'm doing. So go ahead and do that. I get 21x minus 35y plus 14z equals negative 56. And then in my second equation, I get 10x plus 6y minus 14z equals 0. And then I'll add, just like I've been doing for everything else I'm doing with two systems, right? And I end up getting 31x minus 29y. I just had to double check that that was in fact 6 and 35. Now the z's cancel just like I wanted, and it equals negative 56. So I've eliminated one variable. Sweet. So I eliminated z. I'm going to do the same process again with 2 different equations, and I'm going to do it over here in a different color. Unfortunately, I still have 2 variables, so I can't just go ahead and solve from here. I have to do an elimination of z over here, and then I can use both of those equations. So let's do an elimination of z. I think I'm going to do the first one and the second one. So 7z plus 7x plus 5y plus 3z equals 16, and 3x minus 5y plus 2z equals negative 8. Yes, okay, good. Now I need to figure out how to eliminate z. Well, one of them is already negative, that's good. So I'm going to multiply this one by 2 to get negative 6, and the second one by 3 to get positive 6. When I do that, I end up with 14x plus 10y minus 6z equals 32. And I have 9x minus 15y plus 6z equals negative 24. Alright, equals negative 24. And I'll go ahead and add. So I'm just multiplying, adding, multiplying, eliminating. 14 plus 9 is 23. 10 plus negative 15 would be minus 5y. The z's cancel, just like I want them to. And 32 minus 24 would be positive 8. Alrighty, and again I end up with a 2-variable system. So now I have this new system. I'll write it in blue. I have 31x minus 29y equals negative 56. And I have 23x minus 5y equals 8. Now I can solve this with elimination. So I've done elimination once, twice. I'm going to do it one more time to get rid of these variables, get rid of the last variable. And actually, you know what? I'm just going to rewrite this over here to the left so that we have some room. So rewrite this. So I've got
31x minus 29y equals negative 56. And 23x minus 5y equals 8. I think I'm going to go ahead and eliminate that y. Alright, I'm going to eliminate the negative 5y and the 29y. So I need to find two things in common. I don't think I'm going to find much in common except the multiplication of each other. So I'm going to multiply this first one by 5. And the second one by 29. Alright. So the first one I end up getting 31 times 5. 155x minus 145y equals negative 280. Second one, I end up with 667x minus plus, let's make this one negative. So we'll make this negative 129. So negative plus 145y. And then negative 29 times 8 is negative 332. Alright, I'll add these together. And it looks like the y's are going to eliminate, which is great. Oops. Negative 667 plus 155 gives me a negative 512. And over here, negative 280 plus negative 332 gives me a negative 512. And therefore, x is equal to 1. Awesome, I solved for x. Now I'll go back and solve for y. So once I found my first variable, so I've eliminated. Now I'm going to plug into solve. Excuse me. Alright, so I think I'm going to go back to this equation because it's kind of smaller. So I have 23 times, let's use a different color, let's use purple. 23 times what I now know about x is equal to 1, minus 5y is equal to 8. So 23 minus 5y is equal to 8, minus 5y is equal to negative 15, y is equal to positive 3. Alright, so I found y. Now I'm going to take both of these guys and I'm going to go back to my original equations way up when, and I'm going to solve for that z, the first one I eliminated. So let's do this one in orange. I've got 7 times 1 plus 5 times 3 minus 3z is equal to 16. I am using that first equation to solve for z. So I've plugged in what I know. I know x is 1 and y is 3. Now I can solve that out. 7 plus 15 is 22. Minus 3z is equal to 16. And so minus 3z, subtract 22 from both sides, is negative 6. I get z is equal to 2. So I get the coordinate pair of 1, 3, 2. 1, 3, 2 as my solution. That's a three-dimensional point in space. That is about 1 out, 2 out, 1, 2, 3 up. So it's like right about there. Kind of hard to tell in two dimensions, but that's what it looks like. Kind of a point there. And that's how you'd solve a three-variable, three-equation system. Again, no, you will not need to do that on the test. I just think it's super cool that you can get up to stuff in 3 dimensions with things we happen to be learning in this class. So I thought I'd show you one, but you will just be responsible for being able to solve them, stuff like this, and for using substitution, elimination, and graphing as well. Alrighty. If you have any questions at all, please ask them now. Otherwise, you may begin your homework. And I will see you in 4.2.